Let's just jump right in. Welcome to today's Explainer, where we're going on a wild ride from classic, tried and true chemistry techniques all the way to the absolute bleeding edge of modern material science. We're going to connect the dots between how we purify everyday chemical compounds and the mind-bending properties of what scientists are calling the material of the future. It's a perfect example of how getting a grip on the basics literally hands us the keys to unlock tomorrow's technological miracles. Here's the game plan for today. First, purifying through crystallization. And second, we'll dive into graphene, the miracle material.
All right, Section 1, Purifying through Crystallization.
This classic textbook method we're looking at really sets the stage for everything we do in the lab. It's a foundational process that lets us take an impure compound, specifically potassium nitrate, and completely purify it through a process called crystallization in water.
Before we get into the actual steps, you really have to understand the engine driving this whole thing. We call it the solubility principle. Honestly, it's just like kitchen chemistry. Think about stirring sugar into a mug of piping hot tea versus a glass of iced tea. You know how the hot tea dissolves way more sugar? Well, as our source points out, the solubility of potassium nitrate increases with temperature. That heat lets the water absorb and dissolve so much more of the solid compound than it ever could at room temperature.
So, how do we actually use that principle? Let's break down the first 3 steps. Step 1, we prepare our solution. We take our impure potassium nitrate and dump it straight into that hot water we just talked about. Then, step 2, filtering. While the whole mixture is still nice and hot, we run it through a filter. Why? Well, this instantly yanks out any insoluble impurities or undissolved junk, leaving us with a perfectly clear, hot liquid. And then, step 3 is where the magic starts, cooling the solution. As we slowly lower the temperature of that filtered liquid, the water's ability to hold onto the potassium nitrate drops. This temperature drop literally forces the compound to start forming solid crystals. And right as our solution is cooling down, we move right into the final crystallization steps. Interestingly enough, this also opens the door to our next major topic, graphene. But let's finish up our purification first. Okay, picking right back up, step 4 is crystallization. As the cooling continues, something absolutely amazing happens at the molecular level. Pure crystals of potassium nitrate lock into place. And because this crystal lattice forms in such an orderly, structured way, it naturally kicks out the remaining impurities, just leaving them behind in the liquid. Step 5 is isolation. Now that we have a solid and a liquid, we just separate our shiny new crystals from the leftover liquid using filtration or a pouring technique known as decantation. Finally, step 6, drying. We get rid of any lingering water, and what we're left with are beautifully shaped, 100% pure crystalline solids. Boom! We've successfully separated the pure compound from its messy, impure starting state. Moving right along to Section 2, graphene, the miracle material. All right, now that we've totally mastered purifying traditional compounds, let's shift gears completely. We're looking at a material so incredibly unique and so vastly different from traditional bulk crystals that it's quite literally changing the future of electronics. What's truly mind-blowing here is the sheer elegant simplicity of this stuff at the microscopic level. Graphene isn't some super complex multi-element concoction. It is simply carbon, just a single solitary layer of carbon atoms arranged in a flat hexagonal lattice. Honestly, it looks exactly like microscopic chicken wire. And because of that unique hexagonal atomic structure, graphene boasts a rapid-fire list of incredibly desirable traits for the electronics industry. Our source points out that it's ridiculously lightweight, it's a fantastic conductor of both electricity and heat, it's totally transparent, meaning light passes right through it, oh, and it's highly flexible too. Just take a second to let that wild combination of traits sink in. But wait, here is the absolute most staggering fact we need to highlight. Despite being just a single layer of atoms, and despite being so flexible and lightweight, this hexagonal lattice is ridiculously strong. To put it in perspective, it is about 200 times stronger than steel. No way, right? This comparison perfectly illustrates why scientists are geeking out over this stuff. It's a material of total contradictions. On one hand, it's practically invisible, weighs almost nothing, and bends like paper. But on the other hand, it has enough structural integrity to put heavy-duty industrial steel to absolute shame. It's exactly this specific combo, insane strength paired with being incredibly lightweight, that makes it the holy grail of material science. And the best part? This isn't just science fiction. It's happening right now. This crazy combination of strength, transparency, flexibility, and conductivity is exactly why graphene is completely revolutionizing the electronics industry. The text shows us it's already being used in advanced transistors and highly sensitive sensors. Its flexibility is paving the way for truly bendable electronics, and since it's both conductive and transparent, it's literally the perfect material for the touchscreens on our smartphones, super high-efficiency solar cells, and all sorts of other optoelectronic devices.
It really makes you wonder, doesn't it? As we wrap up today's explainer, I want you to step back and look at the journey we just took. We started with the basic, foundational textbook method for purifying a simple salt in water, and we ended up talking about a single layer of carbon atoms that is actively reshaping our entire technological world. Getting a handle on foundational chemistry today is absolutely the key to unlocking the miracle materials of tomorrow. So, if a single, invisible layer of carbon atoms can completely revolutionize modern technology, what other miracle materials are just waiting out there to be discovered? Keep exploring, guys.